Hello friends, in this video we are going to discuss the previous year GATE question number 19. This question is from GATE 2013 examination. Let us read the question. Thyristor T in the figure below is initially off and is triggered with a single pulse of width 10 microseconds. Okay, it is given that L value is 100 by pi microhenry and C is equal to 100 by pi microfarad. Okay, assuming latching and holding currents of the thyristor are both zero. Okay, so latching current and holding current values are zero. The initial charge on the capacitor is zero. T conducts for. Okay, and they have given the four options. Okay, so our task is to find the conduction time of the thyristor. Okay, so this is very simple. It is simply related to the class A commutation circuit. Okay, so here if you check, latching current is equal to holding current is equal to 0 ampere they have given. Okay, L value is 100 by pi microhenry. T is also given, it is equal to 100 by pi microfarad. Okay, so this is the capacitor's value they have given, right? Next, initially thyristor is in an off state. Okay, so suppose at t is equal to 0, at t is equal to 0, yes, thyristor T is turned on. Thyristor T we have turned on by using the gate signal. Okay, so for t greater than 0, for t greater than 0, yes, if we apply the gate signal and our thyristor will turn on. So at t is equal to 0 we are applying the gate signal, and for t greater than 0 our thyristor will act as a short circuit. So circuit will be like this we are having. Okay, so this type of circuit, yes, we will be having. So the voltage across the circuit is 15 volt. Okay, inductor value here, it is a capacitor. Okay, so after t is equal to 0, yes, we can find the current flowing through the circuit. Okay, for the class A commutation we have already find, yes, for the class A commutation we have already simplified this type of circuit. Okay, so what is the current in the circuit? Yes, we are having the expression I is equal to Vs into under root C by L. Okay, Vs is nothing but the 15 in this case. Okay, so here we can write Vs is equal to 15. So Vs into under root C by L into sine of omega 0 t, where omega 0, is equal to 1 by root LC. Okay, so this expression, right, I is equal to Vs under root C by L into sine of omega 0 t, this expression we have already derived for this circuit in the class A commutation. Okay, so here, so we can directly use this expression I is equal to Vs under root C by L into sine of omega 0 t. Okay, so first can we find omega 0? Yes, omega 0 is 1 by root LC. Okay, omega 0 is 1 by root LC. Next, so here current is having a nature of sinusoidal, right? Current is a sinusoidal. So if you check the current in the circuit, it is a I, it is a sinusoidal one, right? Current in the circuit is a sinusoidal one. So suppose it is a T, so current is having a this type of the waveform, it is a sinusoidal one. Okay, so if you check current in the circuit at this instant, current in the circuit at this instant, current in the circuit becomes 0, means the current flowing through thyristor becomes 0. So current is 0 means what? It is a less than the holding current value, so definitely our thyristor will turn off. Okay, so at t is equal to 0 we are turning on a thyristor, and at this instant our thyristor is turning off. Okay, so what this instant, this angle indicates, this angle is pi radian. Okay, so here can we say that the time corresponding to this interval is equal to what? It is a pi by omega 0. It is equal to pi by omega 0. Is this clear? Okay, so thyristor will be in the conduction mode only for pi by omega 0, means from this instant to this instant, that is equal to pi by omega 0. So we can write, so therefore conduction time, conduction time of thyristor T is equal to what? Pi by omega 0. So it is like pi by omega 0 is 1 by root LC. So it is a 1 by root LC. Okay, so it is like a pi into root LC, pi into root LC. Okay, so we can write it as a pi into under root LC. LC is, L is 100 by pi and C is 100 by pi, right? Microhenry, microfarad. So it is 100 by pi into 100 by pi, right, into 10 to the power minus 6 into 10 to the power minus 6. So I am writing it as a 10 to the power minus 12. Okay, so if you check, it is equal to, yes, 100 by pi, 10 to the power minus 12. Okay, so it is like 100 into 10 to the power minus 6, 100 into 10 to the power minus 6 seconds. That is nothing but the 100 microsecond. 100 micro. Okay, so this is nothing but the conduction time of thyristor T. Okay, so this is conduction time of thyristor T, right, is nothing but 100 microsecond. Nothing but 100. Is this clear? So is this, are you getting the point? So after T is equal to 0, the current starts flowing into the circuit, and this expression of the current, yes, is very important, because in class A commutation, class B commutation, right, class D commutation also, we have used this expression, we have derived this expression multiple times. Okay, means if the supply is DC and if circuit consists of only L and C elements, then the nature of the current will be like Vs under root C by L into sine of omega 0 t, means it is a sinusoidal one. Okay, so current in the circuit is sinusoidal, means at this instant the current flowing through thyristor becomes 0. Once current flowing through thyristor becomes 0, yes, thyristor current becomes less than the holding current value, so thyristor will turn off, right? So therefore the conduction time of thyristor is nothing but only this much. Okay, and this time is nothing but pi by omega 0, or this angle is pi. Omega 0 t is equal to pi, right? This angle is pi. Okay, if this is a omega 0 t, then it will be a pi. Okay, so time will be pi by omega 0. Time will be pi by. Is this clear? So this is about, and if you check the answers options, correct option is option C. Okay, so this is about the question number 19. In the next video we are going to discuss the question number 20. Thank you.